Good morning, dear students. So we have talked about combination reaction in the last lecture. Today we will talk about decomposition reaction. What do you understand by decomposition? Decompose means decombination, breaking down into simple substance. It's just opposite of combine. In combine we require two or more, and it gets form only one element or one compound. In case of decompose, what happens? When a chemical compound decomposes on heating or absorbing some other kind of energy. So during decompose, a substance wants some energy, whether heat energy, electrical energy, or sunlight, photochemical energy. Some kind of energy is absorbed by that compound and then it breaks up into simple substance. So when a chemical compound decomposes on heating or absorbing some kind of energy, so as to form two or more new substance. For example, there is an AB compound. There is a compound AB, which on applying some heat energy or sunlight or electric current, it breaks up into A plus B, or sometimes A plus B plus C also. So such kind of reaction is known as decombination reaction or decomposition reaction. Let's take example of calcium carbonate. Calcium carbonate is limestone. On heating, it decomposes into calcium oxide and carbon dioxide. So this is called thermal decomposition. Why it is called thermal decomposition? Because thermal means heat energy. If the compound is breakdown with the help of heat energy, it is known as thermal decomposition. And the application of calcium oxide is actually widely used in industry, because calcium oxide is lime. So lime is used for making lime water, and there are so many applications in the industry. So by thermal decomposition, calcium carbonate can be converted into calcium oxide and carbon dioxide is released. So this is known as thermal decomposition, and delta sign is of heat energy. Same way, if we are heating lead nitrate, if you are heating, we will get reddish brown fumes of nitrogen dioxide. So PbNO3 twice. On heating, it will form a yellow color compound lead oxide, then reddish brown gas is evolved and oxygen gas is also evolved. So you can see a one compound lead nitrate, on heating it will convert into 1, 2, 3 compounds: lead oxide, nitrogen dioxide, which is a gas, reddish brown fumes will. So reddish brown fumes evolution will conclude, or we can say will give us idea that this compound is break down into lead oxide and nitrogen dioxide gas. So this was about thermal decomposition. Now let's talk about photochemical decomposition. If the substance are decomposed with the help of sunlight, yeah, it happens like silver bromide, silver chloride. If you just keep just in a, we can say, on a plate, and there is a diffuse sunlight of coming from the window, or the direct sunlight coming from the window, what will happen? Silver chloride, it is a compound. On exposed to sunlight, it will slowly decompose into silver and chlorine gas is evolved. Chlorine is a gas. So silver chloride is a solid substance which on exposed to sunlight, the chlorine gas will evolve out and the left remaining will be silver color, silver element. So in this way, it is also used in black and white photographic films. Like silver bromide is used in photography films, black and white. So on exposed to sunlight, it forms silver and bromine gases evolve. So in this process, the decomposition takes place with the help of sunlight, and that's why it is known as photochemical reaction. Photo means light, because the particles of light are known as photons. So the reactions is happening because of sunlight. So it is known as photochemical decomposition because of the breakdown. Silver chloride, silver bromide, both are breakdown into silver, and chlorine and bromine gas are evolved respectively. Such kind of decomposition is known as photochemical decomposition. Now let's talk about the example given in your textbook. The example given in your textbook is of ferrous sulfate. Ferrous sulfate contains water molecules, that's called water of crystallization, hydrate molecule. Now on heating ferrous sulfate, what happens? Ferrous sulfate is green color crystal, green color, which is also known as green vitriol. The common name of ferrous sulfate is green vitriol. Ferrous sulfate is green vitriol. So on heating, what happens? Fe2O3 is formed. It is a solid substance. Sulfur dioxide is gases evolved. Sulfur trioxide gas is evolved, and water molecules are evolved. You can see 2 ferrous sulfate, 2 Fe, 2 Fe, 2 sulfate, 2S. Then we have 7 H2O. So 2 sevens are 14 H2O. What happens when you are heating a ferrous sulfate solution? The color of the green disappear, and there is an evolution of gas which is having suffocating odor. Sulfur dioxide is having suffocating odor. These are acidic gas. And SO3 gas is also evolved, but it combines with one water molecule. SO3 combines with one water molecule and forms sulfuric acid. So initially, sulfuric acid was formed first time during laboratory preparation by ferrous sulfate. SO3 plus H2O will form H2SO4, and it appears like a viscous oil. Hence, sulfuric acid is also called oil of vitriol because it was prepared from green vitriol, which is not there in your textbook. I am giving you extra information that ferrous sulfate is one compound. On heating, on supplying heat energy, it get converted into 3-4 compounds: Fe2O3, SO2, SO3, and 14H2O. That is, water molecules are evolving in terms of we can say liquid volume. Water molecules, if you heat further, it will escape into air. So ferrous sulfate is a green color compound. On heating, it changes color because it is converted into iron oxide, sulfur dioxide, sulfur trioxide. Both are having suffocating odor, and sulfur dioxide reacts with water and forms sulfuric acid, which is the oil color. So green color substance disappear. You will see oily layer of sulfuric acid is formed, and sulfur dioxide gas is also formed, which is having a suffocating odor. So this was about decomposition through heat. There is also electrolytic decomposition, which I have to talk separately because it is a very important process known as electrolysis. It is like, let me take an example. Let me give an example of water. Water on supply of electric current will give you hydrogen gas and oxygen gas. Actually, it is quite in a unique way. It is not such like you just supply current in water and it will give you hydrogen gas and oxygen gas. It's not so. There is a specific arrangement, specific we can say apparatus known as electrolytic cell is used, which I am going to discuss in the next lecture. What is electrolysis? What is the apparatus which is known as electrolytic cell or voltmeter? There is a specific anode and cathode, and then if you are applying electric current in that water, then the water molecules will get split into hydrogen gas and oxygen gas. Water is so much stable. If you apply heat energy at 1000 degrees centigrade, 500 degrees centigrade, it will not change, it will not get converted into hydrogen and oxygen. You can't get hydrogen and oxygen just by applying heat energy. And also you can't get hydrogen and oxygen by supplying electric current simply. You required a special apparatus known as electrolytic cell, which I am going to discuss in the next lecture. That is, what is anode, cathode, what is electrolytic cell. But just I want to tell you that idea that due to electric current, water can be decomposed into hydrogen gas and oxygen gas. And if that decomposition takes place by electric current, it is known as electrolytic decomposition. Let's recapitulate. What is decomposition? Breaking down. A compound break down into simple substance with the help of heat energy or maybe electrical energy or sunlight, that is a photochemical decomposition. If it is happening by heat energy, it is called thermal decomposition. If it is occurring by sunlight, it is called photochemical decomposition. And if the decomposition is taking place by electrical, it is known as electrolytic decomposition. Here are some examples. Calcium carbonate, calcium oxide, carbon dioxide. Same way, magnesium carbonate will change into magnesium oxide and carbon dioxide. MgCO3 will give you MgO plus CO2. And there are so many other examples also. Lead nitrate will decompose to lead oxide, reddish brown gas, nitrogen dioxide, oxygen, silver chloride, silver bromide into respective silver and chloride bromine gas. Water is decomposed into hydrogen gas and oxygen gas only during electrolysis in electrolytic cell. So by electric current. And the example given in your textbook, ferrous sulfate, green vitriol, is a green crystal. If you heat that crystal, color will disappear because it will not be FeSO4 anymore. It will get break down to Fe2O3 and sulfur dioxide gas, sulfur trioxide gas, and water molecules are formed. This sulfur dioxide gas and sulfur trioxide gas is acidic gases. They're having suffocating odor, and one SO3 will react with one water molecules and will form oily layer of sulfuric acid. That's why this oily layer, viscous layer appearance, as it is formed from green vitriol, that is a common name of ferrous sulfate. Now this oily layer, as it is formed from green vitriol, that's why sulfuric acid is also known as oil of vitriol. So this is a thermal decomposition. Okay, in the next, if you have any query, you can ask me on WhatsApp, and in the next lecture we'll discuss about others examples and electrolysis. Okay, thank you.